case for second can follow. Okay. Any question on exercise 1? No? Are we good? Okay. You can ask me later if you want. Exercise 2 is about evaluation of source rock maturation. It's quite simple, but as long as you pay attention to what I'm explaining, then you might you won't have any problem in doing it. Okay, here actually we are looking at the burial history. Which actually, as I explained, you have a sediment deposit in the basin, and it's not buried and subsurface. And as we actually know that the geothermal gradient actually increasing downward according to the depth. As depth increased, the geothermal gradient actually increased. Geothermal actually increased. So you start to expose your source rock into certain temperatures. At certain temperatures, at the temperatures around 60 to 120 degrees, that's when you start to generate oil. Yeah. Okay. So here in the exercise says something, says PTI or time temperature index, in which actually the timing the time at which you bury the rock in a certain temperatures. That's what we call a time temperature index. This is the formula how to find this time temperature index. But at this stage, we are not going to use this since we don't know the value of A or the frequency factor. But we are going to use and we don't know the value of activation energy and idle gas constant. We know that, but since we don't know, we have two unknowns, so we are not going to use this. But we are going to find this exposure time using the graph. So say graph 1 and graph 4. Okay, a level of organic maturation. As also you see in your source rock, you have a lot of organic materials, and once it's exposed to the certain temperatures, at this stage we're looking at a 10 Celsius degrees increment. And we assume that the geothermal gradient is actually constant. It's actually about 25 degrees Celsius per kilometer in the earth crust. Okay. This is just a graph about the burial history of the North Sea from the tail end graph. As you can see, you can see here, each line here represented different points. So, for instance, I don't have a map on this one, but for instance, if you are given a map of a project to work on, so every line there, every line here is actually represented by each point, the value history of each point. Say like, so you're asked by your boss to look at a source rock maturation in an area. So you have this point can be taken at any random points in the map that for you to look at. The whole point of here actually that tell you at which area that you can find oil or at which area you can find gas or you can find none at all. That's the whole point of it. The way how to read it, actually you see to find the exposure time. For instance, you want to see how long has the rock buried from 8 to 19 degrees. We have this graph. This is showing the two-point rate generation. So from 80 Celsius degrees, you go along. Once you hit this line, this curve, and you go down, you read it out. So it's only 40 million years. And then go to 90 degrees, go down to 20 million years. 40 minus 20 is 20 million years. So 20 million years, during 20 million years, you expose your source rocks into this temperature range. Here, just in order to give you more clue, I'm just showing you a little bit of a movie that I made myself for my thesis project about the barrier history. Hopefully it works. Yeah. See how you can see that this green one is a carbonate shale, this is the source rocks, and the two yellow one is actually the sandstones from Triassic to Jurassic age. And the top one is another carbonate shale, and these are the limestone which is ours at the top. So as you can see that through different times, the rocks, your sediments actually varied into certain depths. And the next slide, I'm going to show you the temperature model from different points. Here's the slide I've just shown you, and I'm taking three different points here. So 1, 2, and 3. So if you look at point 1, there, barrel history, here actually showing the oil window, it's actually from 60 degrees to 120 degrees. So within the time frame of, let's say around 225 million years, up to about 175 million years. The source rocks at this point, they pretty much generate oil. So if I want to explore in this area, right now it's actually beyond my oil windows, so I can't find any oil. If I want to explore here, so there's no oil anymore that's really generated here to recharge my reservoir rock here. So now, but if I want to find at point 2 and 3, I have a lot of hopes because it's actually still right now it is still located within the oil.
So close, no matter